for you to find a quadratic equation whose roots are these, okay, you need to make use of the given equation, and that is where you need to start from. Okay, now consider the given equation, which is x to the power of 4 minus 2x raised to the power of 3 then minus 1 equals 0. So let's call this to be equation 1. Don't forget the roots of this equation here are alpha 1, alpha, beta, gamma, and delta. These are the roots of equation 1. Okay, so now the root of the new equation we are trying to find are alpha cubed, beta cubed, gamma cubed, and delta cubed. So which means that we can represent that one to be y equals x cubed. So the new equation now will be in terms of y. For that to happen, we need to eliminate x in equation 1. So where you can just make x as the subject of formula here, and that's going to be y raised to the power of 1 over 3. So let's call this to be equation 2. So for you to get rid of x in equation 1, you substitute equation 2 in 1 so that everything in equation 1 becomes a polynomial in terms of y. Okay, so by substitution now equation 1 becomes y raised to the power of 4 over 3 then minus 2y minus 1 equals 0. So in this equation that we obtain, this is not a polynomial. Why? Because of this power 4 over 3. Okay, and this is the only unique term here. What we just need to do is to separate it from the remaining terms. So this is y raised to the power of 4 over 3 then 2y plus 1 equals to y plus 1. Now what's next here? In order for you to get rid of the non-integer power, so you can just take cube of both sides, so which is y raised to the power of 4 over 3 all cubed then 2y plus 1 all cubed. Okay, so this becomes y raised to the power of 4, and by expansion this should give you 8y raised to the power of 3 plus 12y squared plus 6y then plus 1. And of course this is a quadratic equation, which will finally be y raised to the power of 4 minus 8y cubed plus 12y squared, sorry, that should be minus down, minus 12y squared then minus 6y minus 1 equals 0. So this is the new equation, and the equation has the root of alpha cubed, beta cubed, gamma cubed, and what? Delta cubed. So let's call this to be equation 3. Okay, so to make this clear now, let's alpha 1 be alpha cubed, beta 1 be beta cubed, gamma 1 be gamma cubed, and delta 1, gamma 1 equals gamma cubed, and delta 1 equals delta cubed. Alright, so which means that if you are to write your recurring equation in terms of x, that's going to be x1 or so. Now that is all about the first part of the question. So the second part here is you need to find this. Okay, 1 over alpha cubed, 1 over beta cubed, 1 over gamma cubed plus 1 over delta cubed. Okay, so for us to get that, first thing first, let me write out the expression 1 over beta cubed, 1 over gamma cubed, and 1 over delta cubed. Alright, what we have here can be written as 1 over alpha 1 plus 1 over beta 1 plus 1 over gamma 1 plus 1 over delta 1. Remember, I've represented everything to be in terms of alpha 1, beta 1, gamma 1, and delta 1. That is why you can easily change it to this. Okay, and what this really means is x minus 1. Okay, x minus 1. So but let me just put prime here just to distinguish it from normal x that we have. Okay, now to get this one, the formula to get x minus 1 is the ratio of the linear term. I don't know if you still remember that. Whatever we have here, the ratio of the linear term is going to be the value negative of the ratio, so which is going to be minus 6 over 1. Okay, minus 6 over 1. So the final answer here is going to be minus 6. Okay, now I'm sure you understand that. Now if you don't understand, let me just explain better. Let's say you have a cubic equation of this form: a cubed plus ax cubed plus bx squared plus cx plus z equals 0. X minus 1 here is going to be minus c over d. That's what you are trying to say. This is the linear term that you have here. The linear term is cx plus d. So whatever you have as the coefficient, you take the ratio, then negative of the results. So that's just it. Now I think we actually forget to do something here. Remember, we are asked to state the value of alpha cubed, beta cubed, gamma cubed, and plus zeta cubed, and we've not done that. And what that really means is alpha cubed plus beta cubed plus gamma cubed plus zeta cubed can be written as alpha 1, beta 1, gamma 1, and plus zeta 1, which is x1 prime. So ordinarily it should be x1, but since we are using another notation for that, let's use prime to differentiate from the normal x. So x1 is the sum of the roots, which is going to be what? 8. So this will give us 8. Okay, so the last part of the question, you need to find, which is C. You have to find alpha to the power of 4, beta raised to the power of 4, gamma raised to the power of 4, and delta raised to the power of 4. So everything here is same as x4. Okay, you don't need to use prime here. This same thing as x4. And of course, the given equation is actually a quadratic equation. So we can find x4 from the given equation, not from the derived equation. So the given equation, remember, it is given to be x raised to the power of 4 to x raised to the power of 3, then minus 1 equals 0. And of course, the recurring equation here is going to be x4 minus 2x3, then minus 1 times 4 equals 0. Okay, so x4 minus 2, x3, we've gotten that to be 8, then minus 4 equals 0. Okay, so when you do your maths very well, 2 times 8 is 16, plus 16 plus 4, that's 20. So that means x4 now is going to be 20. Okay, and that is the final answer there. Okay.